In this video, we will go over binomial distribution. To begin, let me define what a Bernoulli trial is. A Bernoulli trial is a process that results in exactly one of two possible outcomes. Since there are only two possible outcomes, we will arbitrarily label one of them S and call it success, and the other one will be labeled F and will be called failure. P will denote the probability of success, and therefore 1 minus P will denote the probability of failure. Also, the probability of success remain unchanged from trial to trial. All right, so now I define Bernoulli random variables. So if I have a Bernoulli trial, there are two possible outcomes, S and F. Let's define a random variable x as follows. X is 1 if S occurs, and x is 0 if failure occurs. Then the PMF of x is given by P of 1 is P, P of 0 is 1 minus P. This random variable x is called a Bernoulli random variable. Let's now define binomial random variables. Let's let n independent trials be performed where each results in success with probability P and in failure with probability 1 minus P. So we have n Bernoulli trials. The probability of success is P, the probability of failure is 1 minus P. Define the variable x to be the number of successes in n trials. N is fixed here. X is called a binomial random variable with parameters n and p. And I'm going to use the notation x tilde b of n comma p to express that x is a binomial random variable with parameters n and p, where n means the number of Bernoulli trials, p is the probability of success. Let's do an example. Let's look at the case when we have 5 Bernoulli trials, so n is 5, and in that case the binomial random variable x will be the number of successes in 5 trials. Now observe, an outcome of the 5 trials is a sequence or permutation of S and F of length 5. For example, SS is a possible outcome of the 5 trials. So let me now list out the elements of the event x equals to 0. So x equals to 0, what are the elements given by what are the sequences of S and F that are associated with x equals to 0? Well, x equals to 0 means 0 successes. Well, that would mean that all 5 trials result in failures. So this event is the event that we get 5 failures. Okay. Now, what's the probability then? What's the probability then that x is 0? The probability that x is 0 then is the probability that I get five failures. Well, that is equal to, since the trials are independent, I can say this is the same as the probability of getting a failure on the first trial, probability of failure on the second trial, probability of failure on the third trial, times the probability of failure on the fourth trial, and the probability of failure on the fifth trial. Let me make some room here. So then this is equal to, so then the probability that x is 0 is, well, the probability of f is 1 minus p. So I get 1 minus p times 1 minus p times 1 minus p, 1 minus p, 1 minus p, which is 1 minus p to the 5. Now I am going to rewrite this as 5 choose 0. Remember, 5 choose 0, that binomial coefficient is equal to 1, and I can so then say this is 5 choose 0 times 1 minus, actually let me write it a little bit differently. So finally I'm going to say, I guess I should make a little bit more room. So finally I will be saying that the probability that x is 0 is 5 choose 0 times p to the 0, 1 minus p to the 5. Why I am rewriting the probability in this way will be clear in a bit. Okay, so let's now look at the event x equals to 1. Okay, so let's list out the elements of that event. X equals to 1 means that x equals to 1 means that I have we get 1 success and 4 failures, right? So 1 success and 4 failures can occur in the following way. So the first one may be a success, and then I get failures in the remaining trials, or I might get F, S, F, 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 or F, F, S, F, 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 S, F, and F, 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 S, and these are all the possible. So the success can come from any of the 5 trials. So there are 5 sequences of results from the 5 trials where I get exactly 1 success. So the number of elements of the event x equals to 1 is then 5, which can be written as 5 choose 1. And what's the probability that x is 1 then? Well, in order to calculate that, so we're now going to try to calculate the probability that x is 1. In order to do that, first of all, let's pick one of the elements of this event. So let's pick this element here, and what's the probability that I get exactly that sequence of F and S? So the probability that I get failure from the first trial, success from the second, and failure from the remaining trials. Well, again, trials are independent, so this would be probability of F, probability of S, probability of F, probability of F, probability of F, which then is equal to 1 minus P times 1 minus P times 1 minus P times 1 minus P, which then equals P times 1 minus P to the 4. Okay, now there are 5 elements, and all of them are equally likely and distinct. So the probability that x is 1 would be 5 choose 1 or 5 times p to the 1, 1 minus p to the 4. So that's the probability that x is 1. Okay, because the probability of each element is p times 1 minus p to the 4. So the probability of the 5 elements, in order to find the probability of the entire event, I have to add up the probabilities of the individual elements. And if I add up the probabilities of the individual elements, I get 5 times p to the 1 times 1 minus p to the 4, because the probability of each one of them will be p times 1 minus p to the 4, right? It doesn't matter the order of S and F, as long as I have exactly 1 S and 4 Fs, the probability will be the same, or the probability will be equal to p times 1 minus p to the 4. Okay, so let's look at now the event x equals to 2. Now I'm going to look at this case backwards. So I want to first come up with the number of elements belonging to the event x equals to 2. Well, if x is 2, that means there are 2 successes and 3 failures. So look at 2 successes and 3 failures. Now I'm looking at this as 5. I have 5 symbols. 2 of them are S, and the remaining 3 are F. So I have these 5 symbols. So basically, in order to count the number of ways I can get 2 successes and 3 failures, I basically have to count the number of permutations of these 5 symbols where 2 of them are alike and 3 of them are alike, right? So what is the number of permutations of 5 objects where 2 are S or alike and 3 are alike and F? Well, that's the same as 5 factorial divided by 2 factorial times 3 factorial. This is what we learned in the section on counting. Now there is another way of thinking about it. Let me make some room here. Another way of thinking about it is that, okay, so I have a sequence of 5 outcomes of the 5 trials. So think of imagine that I have 5 positions then. 5, so this is the first trial, this will be the 5th trial result. So if I have 5 positions, how many ways can I pick 2 positions for the 2 successes? Right? So once I pick 2 positions for the 2 successes, the remaining positions will be filled out by F's. So if I count number of ways of picking 2 positions from 5 positions will be equal to 5 choose 2. Now we know exactly that 5 choose 2 is the same as 5 factorial divided by 2 factorial times 3 factorial. So either way we get the same answer. So the number of elements in the event x equals to 2 is then 5 choose 2, which by the way is equal to 10. Okay. Well, let's list out the elements of this event now. I know that I have 10 of them, so let's see if I can list them out. So let me start by saying I have S, S, and then F, F, F. That's one possibility. I can get S, F, S, F, F. We can get S, F, F, S, F. We can get S, F, 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 S. Now let's start with all failures. F, 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 S, S. Okay, that's the only way I get 3 F's to begin with. Now let's begin with 2 F's, and then I can get S, F, S. If I have to begin with 2 F's, then I can also get S, S, F. If I want to begin with 2 F's, then so I get FF, SSF. I already wrote FF, SFS. Okay, so then how about we have to begin with only 1 F? Then I get F, S, let's see, F, S, S, F, F. Okay. So right now I have 4 for 8. I can also get F, S, F, S, F. And one more, I can get F, S, F, F, S. and that's right now I have 10 of them. Okay, so those are the elements of x equals to 2. So what I did is I looked at how many, first of all, how many elements we'll start with, we'll have successes in the first 2 trials, how many elements will have success in the first trial and failure in the second one, and then I looked at how many elements will begin with 3 F's, how many elements will begin with 2 F's, and how many elements will begin with 1 F. That's how I listed out the elements. Okay, so then the probability that x is 2, well, there are we see that there are 10 elements, or which is the same as 5. So there are 5. I want to use a red color here. So we have 5 choose 2 elements in this event. Now if you look at the each element has 2 successes and 3 failures, so the probability of each element is p to the 2 1 minus p to the 3. So the probability of each element is that, so the probability of the 10 elements would be 10 times that. Okay, so that's the probability that x is 2. So let me now write out in the case when x is 3, you should check them yourself. In the case the event x equals to 3 will also have 10 elements in it, and I listed out all the elements of that event. And in that case you have again 10 elements, which is actually the same as 5 choose 3. So 5 choose 2, 5 choose 3 are the same. So the probability that x is 3 will be 5 choose 3 times p to the 3 times 1 minus p to the 2. And notice that the probability of each, so in the event x equals to 3, there are each element in the event x equals to 3 has 3 successes and 2 failures, right? So the probability of each element would be p to the 3 times 1 minus p to the 2. And because there are 5 choose 3 elements or 10 elements, I have to, the probability of this event will be 5 choose 3 times p to the 3 1 minus p to the 2. You can look at the event x equals to 4. The event x equals to 4 will have 5 elements, and 5 is the same as 5 choose 4. So basically out of 5 from the 5 trials you want 4 successes, so 5 choose 4, and the probability that x is 4 will be 5 choose 4 p to the 4 1 minus p to the 1. And finally the probability that x is 5 will be 5 choose 4. I have a typo here. This should be 5 choose 5 p to the 5 1 minus p to the 0. So when you have 5 trials, the number of successes could be 0 1 2 3 4 or 5. So I have basically computed the PMF of the variable x. So the probability of x equals to k is then 5 choose k p to the k 1 minus 5 minus k, where k is 0 1 2 3 4 or 5. Okay. Alright, so look at this carefully and make sure that you understand how we computed the PMF. In the next video we'll be looking at the general case when we have n trials.